In this lecture, we will learn about one of the most important building blocks of deep learning, and that is neural networks and neurons. A neural network is a way for a computer to learn how to make decisions by copying how the human brain works. The human brain is made up of tiny units called neurons. Each neuron sends signals to others, and together they help us think, learn, and understand the world. A neural network in a computer works in a very similar way. It uses artificial neurons that take information in, work with it, and pass it forward. These neurons are not living things like in our brain. They are math formulas and functions written in code, but the way they behave is inspired by real biology. Let's take Duolingo, the popular language learning app. When you practice a new language on Duolingo, it gives you lessons, checks your answers, and even helps you with pronunciation. But how does it know what to teach you next? How does it judge whether your pronunciation is right or wrong? Behind all this is a neural network. It takes your answers, your mistakes, your speed, your voice recordings, and your learning progress, and it processes all of that using neurons and layers. Then it predicts what you should learn next or whether your spoken words were correct. This system becomes smarter over time because it keeps learning from all the people who use the app. That's a real example of a neural network at work. Now let's move toward the technical side. A neuron in a neural network is a small unit that receives input. It takes in a number or several numbers, does a small calculation, and gives an output. For example, if you are training a neural network to recognize whether a photo contains a cat or not, each neuron will look at a small part of that photo, like the lines, colors, or shapes. Each neuron gives a result that says, I think I see something important here. These results go to the next group of neurons, which try to make more sense out of them. After many steps, the last neuron says, yes, this is likely a cat, or no, it's not a cat. That's how a decision is made. Each neuron has something called a weight. A weight is like a filter that helps the neuron decide how important the input is. If the weight is high, it means the input is very important. If it is low, the input does not matter much. Neurons also have something called a bias. This bias helps the neuron shift its decision a little, just like someone's personal opinion might affect how they decide. Both weights and biases are numbers that the network adjusts during training. When the network gives a wrong answer, it changes the weights and biases slightly. It keeps doing this over and over until the answers get better. This process is how learning happens inside the network. All neurons are arranged in layers. The first layer is the input layer. It receives the raw data, like numbers, from an image, text, or audio. Then comes one or more hidden layers where the real thinking happens. These layers are called hidden because we don't see what each neuron is doing exactly. It's not visible like the input or the final output. Finally, there is the output layer, which gives us the result. For example, the output might be dog, cat, or no animal. Each layer passes its results to the next one. The deeper the network, that means the more layers it has, the more complex patterns it can learn. That's why we call these models deep neural networks. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. Now let's talk about how we actually build a neural network using tools. We do not have to write every math formula by hand. There are libraries in Python that do the hard work for us. One of the most popular libraries is called TensorFlow, created by Google. TensorFlow allows us to build, train, and test deep learning models easily. It gives us blocks like Lego that we can put together to make a full neural network. TensorFlow is very powerful and fast. It can run on CPUs and GPUs, and it is used in real applications, from recognizing faces to detecting diseases from x rays. But TensorFlow can be hard to read and write for beginners. That's why Google also created Keras, which is like a simple cover on top of TensorFlow. Keras allows us to build neural networks using very short and readable commands. With Keras, you can define layers, neurons, and how they connect in a way that's easy to understand. For example, if you want to create a layer of 64 neurons, you just need one line of code in Keras. It takes care of the details behind the scenes. This makes Keras perfect for students, researchers, and even developers who want to build a deep learning projects quickly. When you use TensorFlow with Keras, the process of creating a neural network becomes smooth and structured. First, you define your input data. Then you add layers, input, hidden, and output. You choose how many neurons each layer should have. You also select an activation function, which is a small rule each neuron follows to make its decision. One popular activation function is ReLU, which is good at helping the network focus on important signals and ignore the rest. For the output layer, if you are making a choice between categories like dog or cat, you might use an activation function called softmax, which turns the numbers into percentages so you can see which one the model is most confident about. After the network is created, you compile it. Compiling means preparing it for training. You tell it what kind of error to look for using something called a loss function. This helps the network know how wrong its answers are. Then you choose an optimizer, which is a tool that adjusts the weights and biases. One of the most commonly used optimizers is called Atom because it works well in most situations. After compiling, you train the network by giving it the input data and the correct answers. This training process repeats many times in cycles called epochs, where the network improves a little more each time. During training, the neural network makes guesses, checks how close it is to the right answer, and then makes changes. This is done using a process called backpropagation. Backpropagation means sending the error back through the network and adjusting the weights layer by layer. It is like telling each neuron, hey, your guess was a little too high. Adjust yourself. These tiny changes add up, and the network gets smarter. At the end of training, we test the model on new data that it has never seen before. If it still gives good answers, that means it has learned well and can be used in real situations. Let's go back to our earlier example. Duolingo. Imagine you are using the app to learn French. You say a word into the microphone. The sound goes into the neural network. The input layer takes the sound wave and changes it into numbers. The hidden layers look at small parts of the sound, like how long it lasted or what tone you used. Then the network compares that to what a correct French word should sound like. The output layer says whether you pronounced it correctly or not. And if many users pronounce the same word differently, the network learns to accept different ways of saying it. That is the power of learning from real data. In many industries, neural networks are now a part of daily life. Banks use them to check if a transaction looks suspicious. Hospitals use them to help detect cancer early. Voice assistants like Alexa use them to understand what you say. All of these systems use different types of neural networks, but the basic idea is the same. Connect neurons in layers, train them using data, and make smart predictions. So, this is a simple explanation of how neural networks and neurons works. See you in the next lecture.